a one kind of resonance, but here alpha hydrogen participating for the stability of the entity of the here it is a carbocation. Now search for the alpha carbon in this species. Here alpha carbon is 0. Okay, for this methyl cation. Next, this is the ethyl cation where alpha carbon is 1. Okay, this is the alpha carbon. Okay, hydrogen attached to alpha carbon is known as alpha hydrogen. Okay, so here alpha carbon is 0, here alpha carbon is 1, and here alpha carbon means if you take this is the main center of the carbon. Okay, means functional group. This is the functional group now because we are considering this carbon positive charge. So this is the functional group, and next attached to carbon alpha carbon. If it is a more carbon than beta, gamma, you can say. So it is also alpha. So in this carbocation, alpha carbon is 2. And now for this is your functional group, you can say, and this is your alpha carbon, this is your alpha carbon, this is your alpha carbon. So here alpha carbon is 3. Now carbon attached to alpha carbon is hydrogen attached to alpha carbon is known as alpha hydrogen. Now here no alpha carbon is there, so here alpha hydrogen is 0. Now here alpha hydrogen is only one alpha carbon, but it attached to 3 carbons, so alpha hydrogen is 3. Now here alpha carbon is 2, and both are attached to 3 alpha hydrogen, so 3 into 6. So alpha hydrogen into 3 into 2, that is 6. Now here alpha carbon 3, and if it is methyl group, so we can say that alpha hydrogen is 3 into 3 into 9. So here is the number rule is more the alpha hydrogen present, more will be the stability of the carbocation. So based on this one, here also this tertiary carbocation is more stable, then 2 degree isopropyl, then ethyl. This is the methyl cation. Okay. Now one hyperconjugation structure for anything I can show you. Let's see. I think I can remove this part now. But this is the structure. Okay. This is the alpha carbon, this is the alpha hydrogen, this is the positive charge. So it is rotating its total carbon. This is also sigma, CH sigma bond. It also has a 2 electron and rotating for the sake of the stability. So the structure is now CH2, CH. Okay. Alpha hydrogen becoming proton, that is H plus M, and the structure is this is the stable structure of the carbocation. Okay. I hope you can draw in your content. So total 9 structure is going to happen, almost identical. Okay. Now we will go for the resonance sequence. Okay. Till now I did not tell you anything about the resonance because we do not need that, because we know I already described the aliphatic carbocation. Now aliphatic or where no saturation was there. Now inorganic resonance structure also. You can see that this is a nitro group. We know that nitro group is a strongly electron withdrawing group. Okay, so as it is already present in the molecule, again fourth position with respect to that one. Okay, so it will withdraw the electron density from your constant primary carbon CH2 carbon, so it will be least stability. But here the same position, fourth position with respect to CH2, but it is as a plus I effect, okay, or plus R effect. It is minus R effect nitro group and it is plus R effect, plus R effect. That means benzene, already we saw here 3 pi bond of the benzene ring helping for the stabilization of this group. So it is also same 3 pi bond already there. Now another factor is attaching OMe2. Its lone pair carbon? sp carbon. Okay, so these 3Z position, we call that is 3Z position carbon is unknown step. Okay, there is no resonance. This is the double bond. You can say it is here, and there one group is here. Where if you write like this, you can find out what I am saying. This is the plus, this is the R. So no resonance is there. Okay, nothing. Double bond is there, but positive charge is on the double bond. This is the highly unexpected. Okay, this is unstable. In any carbon, you can say it is unstable. Okay, because it is already when it is coming from some substrate it came na. It came from some substrate. You can see the X. So if you remove X, it was that time sp2. Now it become sp. Sp means sp hybridized carbon means linear. Hybridized carbon means linear. But this structure cannot attain linearity. Cannot attain linearity. Okay, that's why this is unstable. Generally not forming also. Okay. Now your task is, your next task is for the class. You will bring your notebook. Okay. Provide the rate of reaction for the following species. Following substances. Okay. Suppose I am giving you means I want to tell you towards polypolysis reaction, towards alcohol hydrolysis reaction, okay, okay, which one will rate of reaction? You can arrange that into descending or ascending, or you can say that which one will the highest reaction that will give or lowest reaction.